Fasten your seat belts and prepare for takeoff on a journey of scientific marvel. Air travel has become an indispensable part of our fast-paced lives, yet it's no secret that this convenience leaves a hefty carbon footprint, contributing to global warming and climate change. The environmental impact of air travel is a pressing concern, a dark cloud in an otherwise clear sky. But what if we told you that clean, carbon emission-free air travel might be on the horizon? Yes, you heard it right, and it's courtesy of China's innovative spirit. China has soared high and broken through the metaphorical sound barrier with its latest technological marvel, a plasma electric engine. This game-changer promises to transform air travel, kissing carbon emissions goodbye and carving a pathway toward a greener, more sustainable future. So come along on this exhilarating voyage as we unravel the mysteries of this remarkable engine, how it functions, and its potential role in revolutionizing aviation. What are plasma engines? Plasma engines, a term that may conjure up visions of futuristic sci-fi, are becoming a reality. Known also as plasma thrusters, they represent an electric propulsion system that uses plasma to generate thrust. While this technology is still in its infancy, researchers firmly believe it holds the key to a future of carbon emission-free air travel. Traditional propulsion systems depend on chemical reactions for thrust. Plasma engines, on the other hand, use electric and magnetic fields to ionize gases such as xenon, argon, or krypton. The plasma is then accelerated, producing a force that propels a spacecraft forward. Incredibly, plasma engines can achieve much higher exhaust velocities than chemical rockets, making them perfect for long-duration space travel. But wait, there's more to this cutting-edge technology. Plasma engines stand apart from ion thruster engines, which generate thrust by extracting an ion current from their plasma source. While ion thrusters use grids or anodes to accelerate the ions to high velocities, plasma engines harness the current and potentials generated internally via a high-current electric arc between two electrodes. This results in a lower exhaust velocity than ion thrusters, but it still allows for high efficiency and substantial thrust. One of the main advantages of plasma engines over traditional forms of propulsion is their efficiency. These engines require less fuel, making them more cost-effective and environmentally friendly. Moreover, they are known for their longevity, with some engines capable of running non-stop for years. Plus, the ability to throttle a plasma engine allows for precise control of the spacecraft's speed and direction, a feature highly coveted in space travel. Another advantage is the simplicity of design. Plasma engines don't require high-voltage grids, anodes, or cathodes to accelerate charged particles in the plasma source. This reduces the risk of grid ion erosion, making the engine less prone to wear and tear. Furthermore, the plasma exhaust is quasi-neutral, meaning that positive ions and electrons exist in equal numbers. This eliminates the need for an electron gun to extinguish the exhaust plume. The development of plasma engines has been advancing at light speed, with prototypes already being tested in various space missions such as NASA's Dawn mission exploring the asteroid belt and the European Space Agency's Bepicolombo mission to Mercury. However, much more research needs to be done before they can become a common feature of air travel. Drawbacks of plasma engines. Despite showing immense potential for space travel, plasma engines are not without their drawbacks. One major issue is their high energy demand. For instance, the VASIM VX200 engine requires a staggering 200 kilowatts of electrical power to produce only 1.12 pounds, 5 newtons, of thrust. This means such engines would need massive amounts of energy to be effective for space missions. Pairing the engine with something like fission reactors or advanced solar panels could resolve this issue, but these technologies also bring their own challenges. Additionally, plasma engines can face the problem of plasma erosion. Over time, the plasma can erode the materials of the thruster, decreasing the thruster's lifespan. Solutions like using magnetic fields to contain the plasma are being explored, but they remain in the experimental stage. Lastly, the low thrust of plasma engines compared to conventional rockets can make them unsuitable for launching spacecraft into orbit. They are more suited to missions that require long-duration flight with minimal changes in velocity. Now let's shift gears and return to the Chinese plasma electric engine. At the heart of our discussion, China's innovative plasma electric engine. Recently, Chinese scientists have made an enormous leap in the field of plasma propulsion. They've invented a plasma engine that operates within Earth's atmosphere. Instead of relying on gases like xenon, it uses a mixture of air and electricity to create plasma, which then generates thrust. This innovative approach might make plasma engines a feasible propulsion system for aviation. The Chinese plasma electric engine has been tested successfully, producing enough thrust to potentially power a small plane. While still in its initial stages, this technological leap opens a world of possibilities for the aviation industry. If developed further and implemented effectively, we could see a future where air travel doesn't contribute to global warming. But how does this plasma electric engine help in reducing carbon emissions? Unlike traditional jet engines that burn fossil fuels to produce thrust, plasma engines use electricity. When paired with renewable energy sources for electricity production, these engines could offer a form of air travel that emits significantly less carbon into the atmosphere. Moreover, plasma engines could present a leap in fuel efficiency, potentially outperforming traditional engines 2- or 3-fold. Consider the cost savings and reduced dependence on fossil fuels, not to mention the positive environmental impact. Still, it's crucial to keep our feet grounded amidst this exciting news. A successful test doesn't mean we're ready for a full-scale commercial launch. There are significant challenges that we need to overcome to make plasma engines a reality. Among these challenges are scaling up the technology to power commercial aircraft and addressing the high cost of developing and implementing these engines. Safety, of course, is another paramount concern that needs meticulous attention. Regardless of the hurdles, the breakthrough made by the Chinese research team is a ray of hope. It could be the first step towards a carbon-free future of air travel. As we set our sights on a world powered by renewable energy and geared towards resource conservation, the rise of plasma engines seems to align perfectly. A paradigm shift in air travel is on the horizon, and it's teeming with promise. With plasma engines leading the charge, we are on the precipice of a revolution that could reshape transportation as we know it. So fasten your seatbelts, ladies and gentlemen, we're about to make a quantum leap in aviation. The future beckons, and it looks greener than ever.